Having a quick look here, one thing that I noticed with the left-hand side of the question is that they're not organized nicely. So yeah, equation 1 has the x, then the y, and the constant on the other side. So I'm going to leave it that way. But right away, I'm going to rewrite equation 2. And I'm just going to, that's not an official math symbol, that's just a loop-de-doo arrow. All I'm going to do is rewrite it so that the terms are in the same location. So I want the x first, and then I want to write the term with the y. So to move it to the left-hand side, I'm going to subtract 10y for both sides. And I'm going to leave the 14, or rather the negative 14, on the right-hand side. So that's really what equation 2 looks like. So I'm not even going to acknowledge that middle equation. Right? Here we have equation 1 and equation 2. Do you notice anything odd about equation 1 and equation 2? First of all, I notice that I've got a 6x and a 12x, 5y and 10y, so they're multiples of 2. But the constants on the other side are different. So let's see. I think in order to be able to add the equations that I'm going to multiply one of them, and I'm choosing equation 2, I'm going to multiply one of them by negative 1. So that gives me positive 12x, positive 10y, and positive 14. And actually, I went the long way around. Now I'm going to take equation 1 and multiply it by 2. I'd also considered taking equation 1 and multiplying it by negative 2, and then I only have to do this once, but here we are. So what do I have if I take equation 1 and I multiply it through by 2? Well, I get negative 12x, negative 10y is equal to negative 24. And that's equation 4. Why did I multiply by 2? Well, it made the x's the same. But you'll notice it also made my y's the same. So what happens when I go ahead and add these two equations? So if you were focusing on either x and y and getting them to be the same, have the same coefficients but opposite sign, we would have ended up in the same place. 12x plus 12x is 0. 10y minus 10y, sorry, 12x minus 12x is 0, of course. 10y minus 10y is 0, so the entire left-hand side is 0. I've eliminated the x's and the y's. And what do I have on the right-hand side? I have 0 is equal to negative 10. Is 0 equal to negative 10? No, 0 is never equal to negative 10. So this is nonsense. So if you get a nonsense statement like this, where you don't have any x's or y's, right? It's different from x is equal to 0. 0 is a number. Here, we don't even have an x. We don't have a y. It means that those two lines are parallel. And therefore, there's no solution to this system. They do not intersect. So a nonsense answer is an indication that the lines are parallel. And maybe you recognize that right when we rewrote the equation. Right? If you see that this is going to happen, that those are two parallel lines, that's okay. You don't have to go through the algebra. But if we just go through the algebra, that's where we end up. It's a similar situation over here. These are a little fishy as well. What do you notice about those two lines, equation 1 and equation 2? Maybe you don't notice anything funny at all, but I see that here I have 1x and here negative 2x. So if I just took equation 1 and multiplied it by 2, I'd have 2x for equation 1 and negative 2x for equation 2. So I'm first going to take equation 1 and I'm going to multiply it by 2. So 2 times x is 2x, 2 times negative 3y is negative 6y, and that's all equal to 2 times 9 is 18. And that's equation 3. I'm going to rewrite equation 2. You certainly don't have to, but I'm just going to rewrite it to be very clear that I would like to take equation 3, which came from equation 1, and add it to equation 2. 2x minus 2x is 0. Negative 6y plus 6y is 0, so the entire left-hand side is 0. But the right-hand side, 18 minus 18, is also 0. So that's true. Right? In this case, 0 was not equal to negative 10. That's a false statement. But here we got 0 equals 0. It's not useful to us. It doesn't give me an x and a y. It doesn't give me a coordinate. It doesn't give me one specific answer. But it's a true statement. And what it indicates to me is that these lines are coincident. Or you could just write same line. They overlap at every point. So here we have an infinite number of solutions. So those are the two situations that are odd. You're either going to get an xy coordinate, even if that point is 0, 0, right? Even if you have x is equal to 0 and y is equal to 0, that's a valid point. That's the point 0, 0. It's right at the origin on a coordinate plane. But ones where you don't have an x or a y, you have two options. You'll either have 0 equals 0, which is a true statement, or you'll have 0 equals a non-zero number, some other number, and that's a false statement. If you have a false statement, you have no solution. If you have 0 equals 0, a true statement, you have an infinite number of solutions.